If you're someone who is working in tech right now, it is quite possible that you are suffering from an overwhelming inflow of AI terms and news all day, every day. And I think it is safe to say that a lot of us feel the same way and are experiencing some kind of FOMO or just finding it hard to keep up. Honestly, I feel it is very difficult to grasp all of the knowledge floating around the internet, and even more difficult to pick up a course and see it through without losing interest or focus. But like it or not, AI is definitely changing the way we work, and it is important to stay updated if you don't want your skills to become irrelevant. In this video, I am going to try to explain what I currently feel are the biggest points of traction if you're building something based on AI. Whether you are a developer, product manager, or just a general tech-savvy person, knowing these tools and concepts should give you a great starting point or direction to think about. So, let's start with the most fundamental piece in all of this: models. When people say things like GPT, Claude, or Gemini, what they are really referring to are AI models. You can think of a model as a system that has been trained to understand patterns in data and then generate useful output based on that. For example, a text model can take in a question and generate a response. An image model can generate images from a prompt. A code model can help you write or debug code. Now, the obvious question is, how are these models actually created? At a very high level, these models are trained on massive amounts of data. This includes text from books, websites, code repositories, and more. During training, the model learns patterns, like how words relate to each other, how sentences are structured, or how code behaves. This training process is extremely resource-intensive. It requires huge datasets, specialized hardware like GPUs, and a lot of engineering effort. That is why, in most cases, only large companies are able to build these models from scratch. Even after a model is trained, it doesn't just stay static. Models are continuously improved through fine-tuning, additional training, and feedback loops. This is how newer versions keep getting better over time. Now, if you're building an AI application, the good news is you usually don't need to train a model yourself. Instead, you can use existing models provided by companies using APIs. You send a request with your input, and the model returns a response. This makes it much easier to build applications without worrying about the complexity of training. So in most cases, your focus shifts from building models to effectively using them. And that brings us to the next important piece. How do you actually interact with these models in a way that gives you reliable and useful output? This is where prompting comes in. A prompt is essentially the input that you give to the model. But it's not just about asking a question. The way you structure your prompt has a huge impact on the kind of response you get. For example, if you simply say, "Explain APIs," you will get a generic answer. But if you say, "Explain APIs in simple terms with a real-world analogy in less than 5 bullet points," the output becomes much more structured and useful. So prompting is less about asking and more about instructing. You are guiding the model on what to do, how to respond, and sometimes even what not to do. Now, when you're building an application, prompting becomes a core part of your development cycle. Let's take a simple use case. Say you are building a feature that summarizes long articles for users. At first, you might start with a basic prompt like, "Summarize this article." But you will quickly notice issues. Sometimes the summary is too long. Sometimes it misses key points. Sometimes the tone is not what you want. So you iterate. You might change the prompt to, "Summarize the following article in 5 concise bullet points, focusing only on key insights. Avoid repetition." Now the output improves, then you might add more constraints. Make the summary suitable for a busy professional. Keep it under 100 words. Over time, you keep refining the prompt based on the output you observe. This process of tweaking and improving prompts is what people refer to as prompt engineering. And this is an important shift. Unlike traditional software where logic is strictly defined in code, here a part of your logic actually lives inside the prompt. So building AI applications is not just about writing code. It is also about designing good prompts, testing them, and iterating on them based on real usage. Once you get this right, the model starts to feel much more predictable and useful. And one more interesting thing to understand here is, prompting is also what differentiates products that are built on top of the same underlying models. For example, tools like GitHub Copilot, Cursor, or Claude Code might all be using very similar models underneath, but the experience you get from each of them can feel quite different. And a big part of that difference comes from how they structure their prompts. One product might optimize for fast autocomplete and inline suggestions. Another might focus more on understanding your entire codebase and giving deeper, more contextual answers. Another might behave more like a chat assistant that can reason through problems step by step. All of this is driven by how they frame instructions to the model, what context they provide, and how they guide the output. So even if the base model is the same, the way you design prompts and wrap the experience around it can lead to completely different products. This is why prompting is not just a technical detail, it is actually a core part of product design in AI applications. To make this work effectively, there is one more important concept involved, and that is embeddings. Embeddings are a way to convert text into numbers in such a way that similar pieces of text end up being close to each other. That might sound a bit abstract, so let's simplify it. If you take two sentences like reset my password and change my login credentials, they mean very similar things. Embeddings convert both of these into numerical representations that are also similar to each other. On the other hand, something like book a flight would be very different, and its representation would be far away. This is what allows systems to understand meaning, not just exact words. And this is exactly what makes RAG work. When a user asks a question, that question is converted into an embedding. Then your system compares it with embeddings of all your stored data and finds the closest matches. Those matches are what get sent to the model as context. Let's take a quick example. Say your system has a document that says, employees can take up to 20 days of paid leave annually. Now a user asks, how many vacation days do we get? Even though the words don't match exactly, embeddings help the system understand that these are related, so it retrieves the correct document and sends it to the model. Without embeddings, you would have to rely on keyword matching, which is much less reliable. So in a way, embeddings are what power the search part of modern AI applications. Before we move ahead, there is one small but important concept to understand, and that is tokens. When you send text to a model, it is not actually processed as full sentences or words. Instead, the text is broken down into smaller units called tokens. A token could be a word, part of a word, or even punctuation. For example, a sentence like, "How are you doing?" might be broken into multiple tokens depending on how the model processes it. Now, why does this matter? Because most models have limits on how many tokens they can process at once. This includes both your input and the output. Also, in most cases, the cost of using these models is based on the number of tokens. So longer prompts, more context, and longer responses all increase cost. In simple terms, tokens are what connect your usage to both performance and cost. So while building applications, you need to be mindful of how much data you are sending and how efficiently you are using it. Now, building on top of everything we've discussed so far, there is another concept that has been getting a lot of attention, and that is agents. At a high level, an agent is a system where the model is not just generating text, but is also able to take actions. Instead of a single prompt and response, an agent can think in steps, decide what to do next, and interact with external tools. Let's take a simple example. Say you ask, "Book me a flight to Delhi for next Monday." A basic model might just respond with suggestions, but an agent can go further. It can check available flights using an API, compare options, and even proceed to booking if given permission. So instead of just answering, it is actually doing things. This usually works in a loop. The model receives a request, decides what action to take, calls a tool or API, gets the result, and then decides the next step. This continues until it reaches a final answer or completes the task. So an agent is essentially a combination of a model, some tools, and a decision-making loop. And this is where AI applications start to move from being assistants to actually being operators. Now, once you start building agents that can take actions, there is another practical problem that comes up. How does the model actually talk to all these different tools and systems in a consistent way? Because in a real application, you might have multiple integrations. For example, Google Calendar, email, internal APIs, databases. Each of these has its own format, its own authentication, and its own way of being used. This is where something called MCP, or Model Context Protocol, comes into the picture. MCP is essentially a standard way for models to interact with external tools and data sources. Instead of building custom integrations for every single tool, MCP provides a structured way to expose these tools to the model. You can think of it like a common language between the model and the outside world. Let's take a simple example. Say you are building an assistant that can manage your schedule. A user says, "Schedule a meeting with Rahul tomorrow at 3 p.m. Now, for this to work, the model needs to understand the intent, access your calendar, create an event. With MCP, your Google Calendar can be exposed as a tool with clearly defined actions like create event, check availability. The model doesn't need to know how Google Calendar works internally. It just needs to know what actions are available, what inputs they require. So the flow becomes something like this. The user gives a request. The model decides that it needs to call the create event action. It passes the required details like time, participants, and title. The system executes this using the actual Google Calendar API and then returns the result back to the model. So instead of hard-coding integrations everywhere, you define tools in a standard way and the model learns how to use them. This makes your system more modular and easier to scale as you add more integrations. And when you combine this with agents, you start to get systems that can not only understand what the user wants, but also interact with multiple tools in a structured and reliable way. At this point, you are no longer just generating responses. You are building systems that can actually get work done. So if you step back and look at everything we've discussed, a pattern starts to emerge. You have models that generate responses. You use prompting to guide them. You use embeddings and retrieval to bring in the right context. And then you extend their capabilities using tools, agents, and structured integrations. All of this comes together to form the foundation of most AI applications today. And the important thing to realize is, you don't need to understand everything in depth to get started. Even a basic understanding of these concepts is enough to start building something useful. So instead of getting overwhelmed by all the noise, focus on these core ideas, try things out, and learn as you go. Because at the end of the day, the best way to understand AI is not by consuming more content, but by actually building with it. Give a thumbs if you like this video and subscribe for more.